Welcome back to the session. We see about the numericals in the last topic about the review of optics. The next topic for this session is types of fibers. What are the different types of fibers we are having? If you see the types of fibers, first one is based on the materials used. Based on the materials. Second one is based on the refractive index profile. Refractive index profile. So, first of all, I explain you about the materials we used. Already we have some basic introduction towards the materials. I told in the last class, that is, one is glass, other one is plastic. Now we are discussing about that based on the materials we used. So, types of fibers based on the materials. Okay, based on the materials. So, there are two types of materials are used in the fiber. First one is called as glass and the second one is called as plastic. So, now we are discussing about the fiber. First fiber is called as SCS fibers. SCS fiber stands for the silica clad silica fibers. Your core and your clad both are manufactured by using the glass. Core is manufactured by the glass as well as clad is also manufactured by the glass. And by seeing this, it is also called as all glass fibers. So, having all glass fibers we are having. The one of the beautiful advantages of this one is, of this fiber is, advantage of this fiber is, attenuation is very less. The disadvantages, Are you getting the audio and video? Now please copy that part which is seen on the board. Based on the materials, all the fibers. Please copy it, I will explain once again. Please put a message once it's copying, completing the copying. Is copying completed? Please see here, I will explain it once again. Based on the materials, we are having two types of materials. One is called as glass, other one is called as plastic. If you see here, it is the glass and plastic we have. So, based on these materials, we are dividing the fibers into totally three types. One is called as SES fiber. SES stands for silica clad silica fibers. The clad is manufactured by using glass and the core is also manufactured by using the glass. Here silica indicates as a glass, silica means glass. It is also called as all glass fibers because both core and clad is manufactured with glass, so it is called as all glass fibers. One of the beautiful advantage of this fibers is attenuation is very less, the amount of loss offered is very less. And the second important thing is the disadvantage is nothing but an weight is more and strength is also very less. Strength is very less and weight is very high. We can tell like this: the fiber which is manufactured both with glass, the weight increases and the glass is brittle in nature. If you bend the fiber with small angle also, it will break down because of this brittle in nature, right. So therefore, we cannot have a much strength is present, even though we are including the clad also, that clad is also manufactured by glass. So strength is very, very less. So to overcome these disadvantages, we go for the next one called as PCS fibers, that is called as plastic clad silica fibers. In plastic clad silica fibers, your core is manufactured by the glass, because it is called as silica. Silica is nothing but a glass we are having, and plastic clad, so because the clad is manufactured by using plastic. So what happened is, because of the plastic having some elasticness, because of that elasticness, what happened is, even the bend also, and you can remove it, it comes to its own state. And because of that, we are preferring the plastic clad to reduce the weight also. Both are glass, the weight is very, very high. If you take one part as a plastic, then automatically the weight will decreases. That means weight is moderate, strength is also moderate, attenuation is be less. Attenuation is also be less. Why? Light is passing through the glass, and the core is having that carries the light to the glass. So attenuation offered by the glass is very, very less. But the problem here is, one of the disadvantages is, manufacturing is difficult. When you are manufacturing a fiber, making your core, converting core into a clad, you dope some impurities. When you are doping some impurities, your core will convert into clad. But that clad is of plastic material, means two different materials you are making it, right, which become a very difficult task for manufacturing. So that's why this is having a drawback of manufacturing. So we can't use this practically, right. Next one is all plastic fibers. If you talk about all plastic fibers, the name itself indicates both core and clad is manufactured with plastic. So it's very easy. Why? Because means we have a plastic core, doping some impurities to the plastic core will converts into the clad. This is a plastic clad only. So same material, plastic clad. Then what happened? Advantage, weight is very, very less, because both are plastic. And next important thing is strength is more. Why the strength is more means, it's very important thing is, I already told to you, the plastic will have elasticness. Because of that elasticness, what happens here is, your fiber is going to be having more and more strength. Okay. So even though you bend the fiber also, there is no brittle, there is no breakdown of the fiber. Okay. So until and unless you want to make it to twist the fiber and make to break it, then only it will break, right. So we can handle it. Strength is going to be very, very high. Next one is disadvantages. Disadvantages here is attenuation is very high. Attenuation is very high means the cost of the link will increases. Why? If attenuation is more, then the signal cannot travel for a long distance, and you need more and more repeaters. Repeaters are required to boost the signal. Whenever the repeater is trying to boost in the signals, more repeaters are required, because attenuation is very, very high, and the cost of the link for long haul communication system increases. When the cost increases, by using this plastic fibers, we cannot use that plastic fibers for long distances also. So that's why any of the three type of fibers based on the materials, so SCS fiber, PCS fibers and plastic fibers. So you cannot use the PCS fiber at any cost. The reason is manufacturing is difficult itself. Even though we manufacture also, we can't run for a long range, right. So that's why you can't go for the PCS fiber. Then only alternate we are having is, one is SCS fiber, other one is all plastic fibers. So that's why what you are doing is, based upon the application you select the fiber. Hope it's clear, right. Everybody in the class got this one. Based upon the application we can select the fiber. For example, between the server and server, two servers you are having, those are connecting, the two servers are connecting by using an optical fiber cable. Those are called backbone networks. Those are called as backbone networks. So backbone networks are connected through the your so-called said to be the fiber called as glass fibers. But distribution networks, for example, if you are getting a fiber into your home, which is a distribution, optical fiber cable coming to your home, you use the all plastic fibers. We don't use the glass fibers there, because when you bend it from coming from your window or to any hole, you can blend the fiber, it will break down there only. So that's why, so either the coaxial cable or an optical fiber cable we are using. The optical fiber cable if you use means, that will definitely be an plastic fiber only. That's all plastic fibers are used for distribution networks. So I need to explain you that with a small application, so that you can get a clarity regarding this, where we are using these fibers. Okay. So, please see here, I can take a small example here to explain this with a small example. Bhaiya, we are having two servers. Assume that this is ISP. ISP stands for Internet Service Provider. ISP, Internet Service Provider. Okay. So, service provider का server है. This is one server, server 1, and ISP server 2. It is ISP, Internet Service Provider, server 2. From server 1 to server 2, you are connecting them with an optical fiber cable. These two are connected to optical fiber cable. Whenever the servers are connected to each other, those networks are called as backbone networks. Those are called as backbone network. Backbone network. When you talk about the backbone network that is connecting between the two servers is called as a backbone network we are having. For this backbone network, 99% we go for the SES fibers. Okay, SES fibers are used. Attenuation is very less, and we are going to be having the servers are connected to each other. Transmission of data will be very high, and propagation delay will also be very less, because attenuation is less, number of repeaters requirement is also less. The lag parameter is reduces drastically. And when you talk about a server from ISP server, Internet Service Provider, it comes to your home. Assume that it's a home. Okay, bhaiya. So, a complex, multi-complex we are having like this, and it is coming to the home. So, from ISP server to it is distributing. These are called distributed networks. These are called as distributive networks. Those are called as distributive networks we are having. For this distributed networks, we are going to be using all plastic fibers. We are using all plastic fibers are used. It is all plastic fibers are used, and those all plastic fibers are used for the distributed networks, and this is what said to be called as how the applications, based upon the applications we use it. So, why? Because means here bending is done, and sometimes you are going to be required some strength is more required. Okay, and distribution we cannot do for long distances. For example, in your apartment you are going to putting one small server. From the server you can distribute all the connections are given from that server to the distribute to the home or complete complex or complete society they can going to be distribute. So, this is what the applications, based upon the applications we are using. So, this is completely the classification we are giving, which is with respect to the your based on the materials. Okay. So, I can explain you also another part which is also called as your classification, next classification. So, now to write this example just for understanding purpose I told to you. So, now I can explain you about the another one, another classification based on the refractive index profile. Please concentrate. Based on the refractive index profile, that is called as RI profile. Based on the refractive index profile, that is called as based on the RI profile we are having. When you talk about the based on the refractive index profile, the first important thing we can see here is refractive index profile is of two types. One is called as step index profile. Another one is called as graded index profile. Another one is called as graded index profile. We discuss about the step index profile initially, types of that. Next we go with the graded index profile. When you talk about a step index profile, the refractive index of core and clad are uniform. The refractive index of core and clad are uniform. If you see this one, this is called as a refractive index of core, is called refractive index of clad. This is called N1 and it is called as N2 we are having. So, the entire material at any instant, if you see for delta x or delta L of this one, length of the fiber is equal to L. Throughout the length of the fiber it is uniform, it is L. Throughout the length of the fiber it is uniform. If you see this small piece delta L, this delta L is uniform, the refractive index is uniform here. Same N1, throughout this is equal to N1 only. If you see here it is equal to N2, at this instant it is N2, outside is the air refractive index is also 1, it is common. Now, if you are talking about this entire fiber, the refractive index, just try to understand, this is the your front view of the fiber, which is having core as well as cladding. Now, this is called as the radius of the clad, which is given as R is equal to A. A is called as the radius, 2A is called as the diameter of the core, that is R value is equal to A. R is radius, radius is equal to A. A is the radius of the core, Bhaiya, this is side view, this is the side view of your fiber. I am drawing the profile, such profile is called as the RI profile. Please concentrate, such profile is called as the RI profile. Bhaiya, observe the profile here, this is the refractive index which is called as N2 refractive index. What we study in the classroom is already N1 refractive index is always greater than N2 in our previous topics. N1 is greater than N2 we are having. So, when you talk about N1 is greater than N2, so obviously you knows that, and N2 is definitely greater than N0. N2 is definitely greater than N0, that is also I am writing here. So, that is greater than N0 we are having, which is greater than N0 is the value we are having. Now, see the profile, I am drawing the profile here, changing the color of the profile. So, able to understand very easily, right. Here we have a refractive index of air. Bhaiya, see at this boundary, up to this boundary, we are having refractive index of air. I just draw the boundaries to make it clear. Okay, I just draw the boundaries to make it clear as shown in the figure like this. So, everybody in the class understood this. Now, just try to understand here. This is N0. N0 is the refractive index of air. Now, N0 when compared to N0, N2 is greater. It is greater. See, it is increasing the step. Okay, the width is increased. And N2, it is maintained uniform throughout the length of the fiber. It maintained uniform throughout the length of the fiber. It is called as N2. Am I clear? And again the N2 value is changing to N1. Now you know that N1 is greater. So, N1 is greater means I am writing it is greater and maintain uniform throughout the length of the fiber. And that value is equal to N1 we are having. It is equal to N1. Now again see here, your N1 is now changing to N2 and definitely N2 is high, N1 is small, lesser value. So, the step size width is decreased and become as uniform. So, N2 maintain the uniform. And again N2 is N0 is less when compared to N2, therefore, it is again decreased and this is equal to N0. This is called as RI profile. If you see the refractive index profile, the refractive index profile looks like a step. It looks like step. That is why those are called as step refractive index profiles, we are calling it as. They are called as step refractive index profile, which is called as the written as shown in the figure. I hope everybody in the class understood that it is how we are getting the refractive index. So, the step index profile we are having where the RI profile is given. So, next important point, alpha. Alpha is called as the shape of the profile. Alpha will gives the shape of the profile, also called as profile number also. Okay, also called as profile number also. So alpha is called as the, you can call it as the shape of the profile, or also called as the profile parameter also. Okay, so which is called as shape of the profile or profile parameter we are having, which is also called as profile parameter is present, or refractive index profile, shape of the profile or refractive index profile we are having. It's called profile parameter is present. What is that alpha? Alpha is the profile parameter which gives the characteristic refractive index profile of the fiber core. How the fiber core is present will be given by the your alpha, the shape of the profile or profile parameter we are having. That alpha value is equal to infinite for step index fiber. I hope everybody in the class understood this. How to get this profile parameter, I will explain to you. Take the profile shape and after that you can differentiate that. You are getting some constant or magnitude. The magnitude of that differentiated value of the profile is called as the your profile number or profile parameter or shape of the profile. All are same bhaiya. All are same, different names they are given. But now just try to understand a simple point here. So step signal it is. If a step signal is there, if you differentiate the step signal, every time you are differentiating a step, we get an impulse. Studied in signals and system also. du of t by dt is equal to delta of t. When you talk about du of t by dt is equal to delta of t, we got a step signal, and that step signal you can differentiate it, we get an impulse signal. The magnitude of impulse is infinite, and that's where at here alpha is equal to infinite. Impulse is the signal which is defined by area bhaiya. The area of the impulse is 1, but the magnitude of impulse is equal to infinite. Please remember it. It's not your magnitude is equal to 1. Many students think that magnitude value is 1. No, area is 1, but magnitude is infinite. That's why you have a step signal and you are differentiating the step signal. You got an impulse, and that impulse magnitude is equal to infinite. That is, it gives the shape of the profile, or it is also gives about the profile parameter. So alpha is going to be given here, is called as the shape of the profile or profile parameter we are having. This is completely about the refractive index profile we are having. So I need to explain you about the another important thing, that is how the refractive index is changing. Dekho bhaiya, refractive index is changing NR of R. We are having refractive index, so N of R, because the refractive index is depending upon the radius right now. So N of R is equal to N1 when R value is equal to that of value less than A. Your R value is less than A. So if you see here, the refractive index is now changing with respect to radius. When R is less than A, the refractive index is N1. When R value is greater than or equal to A, when R value is greater than or equal to A, if you observe clearly here, when the R value is greater than or equal to A or greater than A, it is going to N2, refractive index N2. This refractive index is N1. So that is equal to N2. This is how you write the equation. So N of R. So refractive index as a function of radius. If the radius is changing, we can tell very clearly such that it is R is less than A, it lies in the core of the fiber. If R is greater than or equal to A, it touches the claddie, the refractive index is equal to N2. So next point I need to tell to you here is that's about the diagram of the profile. Dekho bhaiya, this is called as the profile diagram we are having. It is said to be called as R. I hope everybody in the class understood this. N of R. So this value is equal to that of N of R, the refractive index, N of R we are having. So when R is less than A, see here, dekho here I am writing here, when R value is less than A, so I can take this value is equal to N1, it is equal to N1. So when R value is A, up to A and up to minus A, okay, so you find out like this, when R is greater than A, then that is going to be equal to that of claddie we are having, okay. So claddie we are having, and the profile is looks like this, and this is for some amount of length, because R cannot be finite, its R is a finite value. So greater than A, we are going to be having a profile which is present like this, N of R, Okay. So, if you confuse the diagram, you can please cross check the diagram here also, there is no issue regarding that. So, if you talk about this diagram, R is greater than A, and that is going to be given as the complete picture we are having. So, N of R is obtained. I hope everybody in the class will understand this, which is called as step index profile we are having. I will explain the types based upon the step index profile. If you please copy it, if you have any doubts, you can please ask me. I can explain those doubts and I can go for the types. Okay. If you see the practical sense here, here also required some R value, that is what said to be called as the diameter of the complete fiber, that is also required to explain that part. Okay. Because the fiber cannot be having up to infinity it is spread, na? Up to some extent it is spread, that is writing like up to some extent. The diameter is also required, or radius of the entire fiber is also going to be required. Okay. Please copy this part. Right. I will explain the types. Please focus here. For the types, that is types of step index fibers based on the diameter of the core. So, types of SI fibers based on the diameter of the core. So, based on the diameter of the core we are having. So, if we talk about this one, see here. So, based on the diameter of the core. So, if we can talk about this value, types of SI fibers based on the diameter of the core. So, please see here. First one is called as SMSI fibers. Second one is called as MMSI fibers. SMSI fibers is called as single mode step index fibers. It is called as single mode step index fibers we are having, which is called as SMSI fibers is present. In single mode step index fiber, the name itself indicates only one mode will be propagate, and that mode is passing through the axial ray. We study about three types of rays: meridional, axial and skew rays. Now it is going to be passing with an axial ray. Only one mode is present, single mode step index fiber, only one mode is present. Actually mode means path, the mode means path we are having. So here we are having one mode, that is transverse EM wave, electromagnetic wave, typically HE11 mode. HE11 stands for hybrid electric 11 mode we are having. So transverse EM wave, that is called as EM mode, that is typically called as HE11 mode we are having. So transverse electromagnetic mode, which is called as HE11, typically HE11 mode is present. Please observe the point number 4 Bhaiya. Don't worry, I will explain all these things in our notes clearly. What's the meaning of mode? Mode means, so only one mode means only one path. All the light will take only one path. Like, strictly speaking, mode means path. Nana. I will study in the EMTL also. One of the mode means the mode itself indicates as a path we are having. One path it is taking. So called as transverse electromagnetic mode we are having. Typically HE11 mode is present. Next important point I want to tell to you is diameter of the core is very small. Diameter of core is very small we are having. Already I told to you such that based on the diameter of the core only we are classifying. Diameter of core is very small and that is called as single mode step index fiber. Diameter of core is large, that is called as MMSI fiber. Because the diameter of core is very small, light will takes only one path to pass through it, doesn't allow multiple paths. Diameter is large, light can be allowed with multiple paths, they will travel in a zigzag fashion. Now next important point, diameter of core is very less we are having. So next we are having the value for getting the HE11 mode, your value of V is equal to 2.405. What is V? V is said to be called as normalized frequency, also called as V number also. It is also called as normalized frequency we are having. The V is called as normalized frequency. The V is going to be giving the relation between three important parameters of a fiber. The three important parameters of the fiber that we are having is nothing but an. The first thing is called as radius, core radius A. The second one is called as delta and the third one is called as V. Okay. So V is also called normalized frequency. V is also called as V number. It is also called as V number, already told to you. Or it is also called as V. Actually what V stand is value of the fiber. It tells the value of the fiber. I hope everybody in the class understood this. It tells about the value of the fiber. So we can relate, V relates, we can write that in the notes Nana, neatly. I can write the formula here directly. Students, please try to understand it. In the notes I can explain. I will explain orally also once again. V relates the radius of the core, relative refractive index difference and lambda operating wavelength. Okay. So that V is going to be given as 2 pi A by lambda into numerical aperture, and that V, because NA is written as like this, 2 pi A by lambda into N1 into root of 2 delta we are having, and root of 2 delta is present, which is said to be called as the V is equal 2.405. If we have the V is equal 2.405, then this mode is possible, only one light ray will travels into the fiber. Okay. So next one Bhaiya. Now coming to the point number 6. Hope you understand all the points I am explaining, like one line I am writing, which will give a brief explanation to you. Right. Now coming to the next one, that is the point number 6 in SMSI fiber. So only one mode is there and the refractive index of core is also uniform. So, light travels with uniform velocity throughout the length of the fiber. So, why? Because means see only one mode we are having, and that mode will travels into the core, and the core is having uniform refractive index. So, it travels uniformly like this with uniform velocity throughout the length of the fiber. So, that means it maintains uniform velocity by a. So, obviously you know what happens if a light ray can going to maintain a uniform velocity, then we can tell very clearly such that there is no dispersion. What happens if there is no dispersion? Dispersion means no pulse spreading by a. If there is no pulse spreading, then we can tell there is no ISI. No ISI means not Indian Standards Institute by a. ISI is inter-symbol interference, studied in communication also. Then there is no errors. Then there is no errors. What is ISI? ISI stands for the inter-symbol interference. It is called as inter-symbol interference we are having. It is called as inter-symbol interference is present. So, this is what we said to be called as your ISI, no ISI is present, inter-symbol interference is present. This is complete explanation about the single mode step index fiber. I can explain once again by taking this with respect to the diagrammatic manner, so that it is very easy for us to analyze it. So, students will obviously understand all these points. By any doubts you can have, you please ask it. So, do not put doubt as a doubt, you can please put in the message as a doubt. I can explain to you that part to you. Okay. There are still some students are putting messages like done sir, noted sir, okay, completed sir, yes sir. So, that is the way of communicating Bhaiya between you and us. See, in the 15 minutes, past 15 minutes, we also have experienced some technical glitch such that strucking the screen completely struck and not getting the information. Okay, I came to note that only when you put a message to me. Okay, that is why I am telling. See, this is an online class, the communication between you and me is only through the chat box only. Okay, because I can't see you and I can't know your feelings also, right. So, you are also seeing me because you can't talk to me right now directly. Okay, I can't see you also, but at least you can see me. Okay, so any doubt you are having, any problem you are facing also, you can please put a message so that I can make it to sort out it, and I can also understand such that you are following or not. Whether you are having any doubt also, please don't think such that it's very easy subject it is. You just need to follow it, that's it. Just completely follow, आराम से follow करो. Any doubt है, you can take it. So, most of the class was going to be in English only. My Hindi is very poor. Basically, I belong to South Indian from Andhra Pradesh state. So, my mother tongue is Telugu. That's why I am not able to speak that much Hindi. I try to speak somewhat of Hindi, Bhaiya, but I can't have a good flow. So, if you have a good flow, you can enjoy it. So, don't think in otherwise. I am learning Hindi, but I cannot have that much good fluency. ठीक है भैया, राइट भैया. कॉपी करने के बाद एक मैसेज छोड़ दो बस. The meaning of mode is nothing but an path. Path means how the light was passing into a fiber. The path that is taken by a light is called as mode. Okay. Sagar, transverse EM mode in the sense means obviously study about the what's the meaning of transverse EM mode. So, meaning of that transverse EM mode, which is going to be typically an electric mode, or if you talk about EM wave, it consists of both electric as well as magnetic. Talking about the transverse EM wave means EM mode means it consists of only either a electric mode or either a magnetic field has to be present. So, here we are taking only electrical field, which is called typically HE11 mode we are using. Okay. Normalized frequency. If you talk about a normalized frequency, Soumya, I need to tell normalized frequency is nothing but it will tell us about the value of your fiber. By seeing the V, you understand how much value of the fiber is there. It relates between your radius of the core, radius of the core or fiber core. Second one is about delta or numerical aperture, and the third one is about the lambda, operating wavelength. That is why V formula is coming like this. V is equal to 2 pi a by lambda. into numerical aperture. Okay, so it will always combine the information about three important design variables of a fiber, and that is called as V. Okay, right. So I got a confirmation from your side about the completion of copying. So thank you for all the students who placed it. Yeah, please concentrate, Nana. 2 minutes concentrate here. We can start explaining you about the diagrammatic manner. देखो भैया ये हमारा फाइबर है, छोटा फाइबर है. एक छोटा फाइबर के लिए डायामीटर है ना बहुत छोटा है, इसी के लिए छोटा फाइबर बोलिए, छोटा भैया. ओके, नेक्स्ट द entire diameter of the fiber is very large. See, just observe it. See, this is the size of the fiber we are having. So from my side I will explain definitely about this size, how much size it is present. It will present from 2 micrometers to 10 micrometers. Some books will restrict it to 8 micrometers also, but many of the books will go up to 10 micrometers. Okay, so I will tell about that part. So what is called as your fiber, which is completely given as the round having 2 micrometers to 10 micrometers we are having. And if you talk about the additional the total length of the fiber, that is total diameter of the fiber. One student asked a very good doubt such that sir, you are giving the A restricted value, but what about this diameter? This diameter is also present by AR Singh. AR Singh asked the doubt in the chat box. That is having the value from 75 micrometers to 125 micrometers we are having. It extends up to 150 micrometers also. Some books will write 150 micrometers, but I don't want to make any complicated or any reasons for explanation of that. That depends upon the design parameter. From one fiber to another fiber they will change. More the diameter, what happens in the sense means they think such that the strength will be going to be high. Because of the strength, the clad strength may be going to be increased. But most of the light is conformed within the fiber only, bhaiya. It goes within the fiber only, most of the light. Okay, so we can't see that such that the diameter of the core is very less. See, very small core of the diameter is present, 2 micrometers to 10 micrometers. That is the one of the first requirement of SMSA fiber. I hope everybody in the class understood, na? So what is the first requirement, bhaiya? Right here I am writing here, A is very small. See, A is very small. See, out of 75 micrometers diameter of the fiber, 2 micrometer is the size of your clad, and the entire thing is present for your core, bhaiya, sorry, for your claddy. So 2 micrometers is present only for the core, and the remaining entire 73 micrometers is present for your claddy. Okay, I hope everybody in the class understood this. Okay, now do you observe one more point also? Here I am drawing that. I wrote here first point, A is very small, and the second point is delta is less than 1%. Okay, so delta is maximum of 1% also we can write. So delta is 1% only, not greater than that. So what is delta? Delta is nothing but a relative refractive index difference, and that will tell about the difference between N1 and N2. So we understand very clearly such that delta is equal to 1% we are having. Bhaiya, clear na? Okay, now see here. All of you please remember these 2 points. Anybody ask you what are the requirements of SMSA fiber in the exam or in the questions, assessing and reasoning also they will ask you. The first thing is diameter must be very small and delta will be equal to 1%. Should be less than or equal to 1%. Right. So maximum value. I can write here to make it clear, delta should be always going to be less than or equal to 1% we are having. Okay, that is the delta value. So by I am changing the color of the pen to understand the profile picture. So please see the profile picture I am drawing here. So देखो ये air है constant and at this instant it is changing. See this refractive index is N2, ये N1 है, ये क्या है N2. भैया diagrammatically I am explaining N1 N2. Now just observe it, the profile is changing. देखो भैया profile changes and definitely N2 is greater, so that's why it is increasing and maintain uniform throughout the length of the fiber. So N2 maintains uniform because clad maintains uniform refractive index. यूनिफॉर्म रिफ्रैक्टिव इंडेक्स N2 मस्ट बी क्या हो गया, मेंटेन यूनिफॉर्मली थ्रू आउट द लेंथ ऑफ द फाइबर. क्लियर ना, राइट. देखो भैया नेक्स्ट वन इज योर N2 इज नाउ चेंजिंग फ्रॉम N2 टू N1. व्हिच वन इज ग्रेटर ना, N2 ग्रेटर N1 ग्रेटर. वेरी गुड, N1 ग्रेटर है, N1 ग्रेटर है क्या हो जाएंगे, मीन्स दिस इज इंक्रीजेस एंड मेंटेन यूनिफॉर्म थ्रू आउट द लेंथ ऑफ द फाइबर ऑफ द कोर. Okay, that is equal to N1. Now after that what you are seeing here, that is going to be changing, decreasing from N1 to N2 and maintains uniform throughout the length of the fiber, and again decreases and maintains uniform throughout the length of the fiber, and that is called as RA profile. See this tells very clearly your diameter of the core is very small. Diameter of core is very small we are having. I hope you understood this one. Just I give the side views and all those things, and here I can give you the your front view. Front view I am giving. This is the front view bhaiya. See, this is the front view. If you see the fiber, if you see the fiber like this, is a front view. This is the front view of a fiber. This is the side view. Side view of a fiber. भैया देखो ये side view है, ये front view है, इधर front view देखेंगे. So front view के लिए इसी तक लगेंगे. Right now, see the diameter of the fiber is very small, and that is equal to R value is very less value we are having. So hope you got it clear na, right. देखो भैया light will travels, just observe it. This is the axis of the fiber. I am showing it with a yellow color line. It's the axis of a fiber. This is the axis of fiber we are having, and the light is passing through a fiber. So I want to take it with one different color. I need to picking blue bhaiya, sky blue bhaiya. Now sky blue color I am picking. See, just see here, light is incident here, reflected back. Light is incident here, reflected back, because all will reflected back, only one mode will be propagated, and that one mode which is propagating to the length of the fiber is called as HE11 mode. See, axial ray. Why all the remaining light rays are going to be reflecting back, they are not passing into a fiber? The reason is very simple, because the diameter is very small. And second important thing is, typically HE11 mode will be propagated. Your HE11 mode will be propagated. Now see, your uniform refractive index of core is uniform, and the light is only one mode is traveling. That one mode will travels very fastly with uniform velocity. With uniform velocity. Now just check it bhaiya, here I am showing it to you. I send a light pulse like this. This light pulse contains only one mode, having only one wavelength, and that one mode and one wavelength is passing into a fiber. At last also you are going to be getting the same pulse, has to be getting. The width of the pulse here and the width of the pulse here is same. Width here and width here is same. When these both widths are same, we can tell there is no spreading. No spreading means no dispersion. No dispersion means no ISI. No ISI means intersymbol interference. Symbols are not interfered with each other. There is no errors. Very important part is that. Okay, what we study in communication system, in PCM, in guided transmission, when you send a pulse, rectangle pulse is transmitted. After traveling some distances, the pulse will get spreading due to the non-linear characteristics of a channel. Okay, because of that characteristics, what happened, your channel is going to be signals, pulses are going to be interfere with each other, and because of that interference, you can going to be find out very clearly such that the pulses are going to be having ISI, intersymbol interference, creates an error where P, probability of error, will be increases. Okay, to avoid that, we use riser cosine pulses there. Okay, to avoid this in optical communication system, we are selecting a fiber. So this fiber has no ISI, no dispersion, no errors. That's the main important thing bhaiya. Now just observe this diagram. I explain all the points to you, and you find out clearly bhaiya. See, I am writing here. You find out clearly. This is called as, what is this called as, Nana? A. What is A stands for? A is called as the radius of the fiber. A is called as the radius of the fiber. Now you can write here. See, number of modes. Students, please concentrate. Number of modes. Writing about the number of modes. Your number of modes is also called as mode volume. It's also called as mode volume. It's called as mode volume, denoted as Mn. denoted as Mn. N stands for number, capital M stands for the modes, number of modes. See, number of modes we are having. The formula is given as Mn is equal to alpha divided by alpha plus 2 into V square by 2. What is V square? What is V? V is called normalized frequency. What is alpha? Alpha tells about the shape of the profile, also called as profile parameter. Both are same, Nana. Some books will refer the different names, but they are same only. So alpha is shape of the profile or profile parameter. V is normalized frequency, tells about the number of modes we are having. Okay, but such V is equal to 2.405, then only we will have single mode. Then only we will have which mode? Single mode. Single mode, and that mode is going to be typically HE11 mode we are having. Typically HE11 mode is present. Okay, typically HE11 mode is present. So this is what said to be called as the single mode we are having. So hope it's clear. So all of you got this one. So most important thing about the single mode step index fiber is there is no dispersion, there is no errors, maintain uniform velocity. Second most important thing is only one mode is propagating to a fiber with having V number 2.405 and diameter is very small, delta should be less than or equal to 1%. So these points are very, very important. If you have any doubt regarding this concept while copying or in this slide, in this particular slide, if you have any doubts, you can please ask me. I can explain that part to you because I will go for the next concept, Bhaiya. Okay. A are seeing the A indicates radius of the core. It is not radius of the fiber, radius of the fiber is different. See here, if you see in this diagram, 75 to 125 micrometers is the diameter of the complete fiber, If you want diameter of the core itself, it is 75 minus 2 micrometers, you remove it, you get the diameter of the core. Okay, diameter of the core. If you want radius also, we can do in the same manner, divided by 2. Okay. So divided by 2. So we need to write a note here. Because of the time constraint, I am not able to explain the note in the today's session. Tomorrow's class we see about the note, and tomorrow's class we will study about the types of fibers and attenuation topic also. Okay, so you will complete the attenuation topic also in the tomorrow's class. So these things, of course, I hope you understand that. Any doubts you can put it. So that's all for the day, students. So, we can see the remaining things in the next class. If you have any doubts, you can please ask. Any slides you want also you can ask, I can make the slides to be open. Okay. So, tomorrow class timing is also same at 6 p.m. to 10 p.m. So, break you can have 15 to 20 minutes, in between 15 to 20 minutes you have a break, like in between 8 to 8:30 you can expect a break, Nana. Okay, that depend upon the concept. If you are in the middle of the concept means I can't stop it. Once the concept is completed, I can give a break to you. Okay, plan according to that. Anybody staying in the PG also or like that also, plan according to that for our supper and dinner. Approximately in between 8 to 8:30 we will get a break. 15-20 minutes break we will get. If I give 8 o'clock means 8:15 or 8:20. If I give 8:20 means like today it may be extend up to 8:40 or 8:15 or 8:35 like that. Okay, so you can make it. You can make your what I am telling is mentally you can prepare like that, because we will go for 50 hours of day, like approximately some 15 days we need to spend along with us for this class. So, that is why you need to be adjust for the timetable of myself. I do not know how the remaining my colleagues or the remaining faculties, the great teachers of MedEasy, how they are followed their schedule. That depends upon the their own convenience. So, the such way what I want to tell to you is, this is what I can follow. Class starts by 6 o'clock bhaiya, there is no doubt about that, and the class ends by 10 o'clock at any cost. Okay. So, remaining things we will see in the tomorrow's class. So, stay safe, good night, Jai Hind. Soumya, I can explain your doubt that V is equal to 2.40 if you are replacing, you are getting Mn is equal to 2 modes, and how the 2 modes are going to present I can explain with the help of polarization. Okay, with the help of polarization I can explain to you. Anunaik, Anujnaik alpha, alpha is nothing but an tells the shape of the profile or profile parameter. Alpha is the profile parameter, okay, which gives the your characteristic refractive index profile of the fiber. How to calculate that alpha is, it is very simple. You can just take the shape of the profile, you can differentiate that. Once you differentiate in the step, you get an impulse. Let the magnitude of the differentiated value. The magnitude of the differentiated value is equal to infinite to get the shape of the profile. In parabolic also we will do the same thing, parabolic profile and triangular profile. I will explain those things also to you in the tomorrow's class. There I can explain to you how you got that profile once again. It always gives that the characteristic refractive index of index profile of the fiber core is given by using the alpha, okay, shape of the profile. Jain, Sejal Jain, one important thing that we can calculate here is, yes, it is okay to calculate it. We can neglect it, Sajal Jain, because 1.402 you are getting and 1.408 approximately, and that question is also a mains question. So, they can give the approximate values, options are be given in the, they do not give that much close options, they will not be given in the ESE exam, so that we can use it. It is a shortcut method to know about our N1 values or N2 values by adding to the delta. Okay. So, you can use that method, no problem. For prelims, for the mains you can use directly because you have a calculator, no problem, you can use it. Kanadidan, value of alpha here is equal to infinite. Value of alpha here is equal to infinite. Tomorrow's class I will make you to do the calculation, how that alpha value will come and what are the parameters that we can take for your alpha value. Okay. So, Aditi Sharma, you are welcome and good night. Sagar, Jai Hind. Keshav, you are most welcome. Good night. So, any doubts, Bhaiya, or can we close the session for the today's class?